Alright, so the name of the game is going to be changing up a little bit here. So now we're going to be doing substituents on our carbon chains. So we're going to start off with just our alkanes. So there's going to be alkanes with substituents hanging off. So pretty much, essentially, like, these are our substituents. This would be a substituent, those lines hanging off the carbon chain, those will be our substituents. So again, this is, so we're going to count our carbons up. 1, 2, 3, 4, 5 carbons. We're gonna want to get our lowest, try to get our lowest number. 2, 3, 4, 5, and then we'll go from right to left. 1, 2, 3, 4, 5. So as you can see, this bottom row puts the substituent, which is that top methyl hanging off that chain, as the lowest substituent. So some may ask, like, can this one right here be our substituent? Yes, it can. This one can also be our substituent. It honestly just comes down to choice. It really doesn't matter. Just in this case, this top one here is a lot easier. Or honestly, just preference. Comes down to preference on which one you'd like. So we know that there are 5 carbons. So we know that we're going to get a pent. And then we know that there's no double bonds and there's no triple bonds. So we know this is pentane. So then we're going to look at our substituent, which is where this methyl is up top right here. So we know this is a methyl because there is 1 carbon hanging off. Another way I guess you could portray this is something like this. So again, with its appropriate attached hydrogens. So definitely, I guess that's also going to be a 3. So we know it's a methyl because it's 1 carbon, specifically this carbon right here, hanging off the end. And we know that 1 carbon is a methyl. So let's get rid of this stuff right here real quick. So we know that is a methyl, and we know it is in the number 2 spot when we counted our carbons. So that'll give us 2 methyl pentane. So that's pretty easy. So then we'll go on to the next one over here. So we'll count our carbons again. So we got 1, 2, 3, 4, 5, 6. And then we've also got some carbons up here. Actually, I'll put those in a different color since they're not a part of the parent chain. So our parent chain will be is essentially, it's the longest carbon chain, and that's always what you're going to look for, and that's what's always going to give you your naming. That's how you get your pent or your hex or your octa or nana or methyl, ethyl, butyl. you're always going to look for the longest chain of carbons. So you're going to count that chain. In this case here, it's 1, 2, 3, 4, 5, 6. So we know it's hex. Oh, different color. So we know it's hex. Then we know there's no double bonds or triple bonds, so we know it's going to be an alkane. And in this case, we have two methyls hanging off the end. Oh, I guess let's we're gonna count to see which number is gonna be the lowest for us here. I'm gonna put them all on the same side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So right here, the bottom numbers here are going to be our lowest. And then we're going to find out where these two methyls are. So the two methyls are located at 3. And since there are two methyls, you do mark 3, 3, dimethyl. So you want to identify that it's 2 with the dimethyl. You always, whether it's dibutyl, diethyl, dipropyl, no matter what, you always, or difluoro, like no matter what it is, if they're both found on the same carbon and it's the same substituent, so like if it's 2 methyls, 2 ethyls, you're always going to put that di in there, or even tri if it's there. Trimethyl, and then your tris or your dis are always going to match up with your numbers. So it's going to be that 3 to indicate the 2 methyls there on that carbon, or to indicate the carbon that they're both found on, and then the number of each that are on that carbon. So then let's move on to our next one over here. So we got 1, 2, 3, 4, 5, 6, 7. All right, so we're going to count our longest parent chain. So right here, you could say 1, 2, 3, 4. Clearly that's too short. So I'm going to get rid of that. So you can go 1, 2, 3, 4, 5, 6, 7, 8. And then I guess if you wanted to start this way, you could also do 1, 2, 3, 4, 5, 6, 7. 5. Oh, I skipped one. That's why. 6, 7, 8. Okay. So take a look at this, and we're gonna see which one's longest. So here you can see that no matter like on both ways how you count it, from left to right or right to left, you have 2 substituents. One's an ethyl, one's a methyl. So in these cases, I always count the largest substituent first. So in this case, it would be this ethyl right here. Or I guess if you would like to take the one up top, but I'm just going to say that one. So this will be our and so this will be our shortest chain, we'll say. So we know there's 8, so it's going to be an oct. And then there's no double bonds, so we know it's octane. I'm going to push this down a little bit. So we know it's octane. So we're going to count 1, 2, 3. And then we get to our ethyl. 1, 2, yeah, ethyl. So when you've got multiple substituents that are different, in this case it's an ethyl and a methyl. So this is our methyl, and then over here, the other circled one is our ethyl. So you always go in alphabetical order. That is the key, is alphabetical order. No matter what, when you're naming, always alphabetical order, not in numbered order. So in this case, it would be like 3 ethyl dash. Oh, and I guess another thing, a good thing to add is you always separate numbers with commas and then words with dashes, and numbers too, and words to numbers, numbers to words with dashes too. So like if you've got doubles like you do over here, you always do a comma. And then so back over here, we got 3 ethyl, 6 methyl octane. So it's nothing crazy terrible. Scroll down a little bit, do some. Alright, so if you want to do those ones real quick, pause the video. I'm going to start to walk you through them and solve them. Okay. So here, we're going to count our carbons up top. So we got 1, 2, 3, 4, 5, 6, 7, 8. And then we got 1, 2, 3, 4, 5, 6. Or you could do 1, 2, 3, 4, 5, 6. So then we know that this one on this count here on the bottom gives us our parent chain because it's the longest chain. So we know 8 is our oct. And then when there's no double or triple bonds, so we know it's octane. And then we know there's a methyl group right here on the 5. And then we know there is an ethyl group right here. So as you can see there, right here, if you count from, you might have to reverse your count sometimes. So it's actually going to go like 1, 2, 3, 4, 5, 6, 7. Actually, I'll do that in a different color. Just get rid of all that. So it's actually going to go 1, 2, 3, 4. Oh wait, nope. Sorry, I had it right the first time. Okay, so our ethyl is actually going to start us off here. So we'll have 4 ethyl, 5 methyl, just gonna scoot that over. Five methyl octane. And then next up is this chain. So we've got 1, 2, 3, 4, kind of amount with you. Right amount. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Also mark these carbons up here. Again, just always remember to just count every which way, no matter what. Can't hurt, because it helps you be right, and you definitely cannot be wrong on these tests, because if you miscount one of these, it can definitely it can throw off the entire compound very easily. So, and then if you wanted to count up here, 1, 2, 3, 4, 5, 6, 7, 8. Clearly that's just short. So we know that's not going to be our longest parent chain. So we know this right here. This right here will be our longest parent chain. And we'll know that that is a nonane, because there's no double or triple bonds. And we see a propyl group here, a methyl group here, and that is it. So then you go alphabetical order, A, B, C, D, E, F, G, H, I, J, K, L, M, N. So we know our methyl go first. So it'd be 7 methyl dash 5 propyl. But I just really need to work on getting these spaced out really. Seven methyl 5 propyl nonane. So pretty easy. And then down below here, count our carbons. 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're going to count these up. So in this case, really, you can pick whichever chain you want as your parent chain. I'm just going to mark these down. Oh, wait. 1, 2. Oh, skipped 4. Derp. Alright, so we got our 5 there. So we know 5 is pentane. Then we've got 2 ethyl groups sticking off. And that'll be 3,3. Diethyl pentane. So again, just always remember to do your parent chain first. Always find the longest chain of carbons, and then count your and then look at your substituents, and then name from there. And always mark and number your carbons. That always helps and figure out. So we've got they're essentially our halogens. So fluorine, chlorine, bromine, or bromine, and iodide. So, if we're starting off here, if you just want to try to name these off the bat, feel free. I'm just going to walk through them. So here, we're counting our parent chain if we're starting on the fluorine here. So we're counting our parent chain of 3, so we know that that'll be a propyl group, so propane, or so prop, and then we know it's all single bonds, so we know it's propane. Then we're going to take, so then we know our fluorine is on the 2nd carbon, so we're going to take our fluorine and give it a 2. So we've got 2-fluoropropane. On the one on the right, so we're going to count our largest parent chain. As you can see, I already have it marked here. We're going to mark our parent chain, so we know it's 6, so we're going to get a hex. And then as you can see, that double bond there, so remember the double bond is you're always going to want to try to give, no matter what, even if there's closer methyl or ethyl or fluoro, chloro groups ahead in a chain, you're always going to want to give the double bond the lowest number, or the triple bond the lowest number on the chain, no matter what. So we're going to take our 2, or we know that's a 2 on the double bond, so we'll get hex 2-ene. And then we're going to look at our methyl group here and our chlorine group. So again, those go in alphabetical order. So we know that it'll be our 4-chloro 2-methyl hex 2-ene. So got that down. I'm going to give some practice problems here. So we've got if you want to give that one a try, I'm going to write out some more. Again, going from compound to name and name to compound is great practice, and it'll really help you out on exams. Cannot stress that enough. It's a lot of things. That's something that a lot of people do not do, and trust me, it makes you lose some very easy points, because that's usually what your teachers will start off with, is just incredibly easy naming problems, which you'll knock out in like 2 seconds if you're good. If you just want to go ahead and pause there, and then I'm going to keep scrolling down. Take that. So I hope as you're watching this, you can tell organic chemistry actually isn't all that bad so far. This is the easy stuff. Hopefully you can stick around and definitely watch it pick up and get way more intense. Just watching those mechanism videos, hopefully. Kidding. They're actually not that bad. Just make some flashcards, knock them out real quick. No biggie. Alright, so now I'm going to give you the answer to these practice problems. So first one up, got 5 chloro, 6 fluoro, 6 methyl, 2 ene. Scoot that over. All right, and then the next one over, we've got 2 di iodo butane. Switch up these colors a little bit. And then next up, we've got 2 bromo, 3, oh, not gonna have enough room for that. 1 second. So here we've got 2 bromo, 3 ethyl, 4 iodo hexane. Really squeezing that one in there. And then next up, shrink this. Next up, we've got our 3 fluoro, 3 methyl hex 2 ene. So that'll should have gotten a structure that looks similar to this. And then next up, we've got our fluoroethane. So should look, oh, should look like so. Just carbon with the fluorine on it, straight line, 2 carbons. And then down here for our 1 chloro, 3 fluoropropane. Just like that. And then for this compound, or the structure over here, we've got 2 iodo, 4 propyl, 5-methyl heptane. All right, and then moving down the list, I'm just gonna drag this one onto. Yeah, I can cross screens. All right, moving down the list, we've got 4,4-dimethyl pentine. So you should have gotten a structure similar to this. Actually, not similar. It should be this.